we are very happy to have you, and we hope you can share also your international experience, share with us, and also, if possible, make a good collaboration with us. Especially this conference is for students, and students is the future of our nation. So it's our work together to get improved. Thank you very much. Enjoy the conference, and good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you for a very insightful opening speech from Mr. Munir. Moving on to the next agenda, opening speech from the Dean of Faculty of Engineering, Universitas Indonesia, Dr. Insinyur Henry D.S. Budiono, Master of Engineering. Time and place is yours.
Well, thank you very much, Mr. Galan Atmagita, who is Master Ceremony of today. Honorary VIP attendance of International Engineering Student Conference 2020. First is management of FTUI and department. I saw Dr. Sahlan, Dr. Munir. Dr. Munir is chairman, and actually he is manager of student affairs and alumni FTUI. And then all steering committee, reviewer and moderator of IESC 2020. The keynote speaker, Dr. Rahmat Adiwibowo from Austrian Institute of Technology. As I know, he is one of our successful alumni. And then Dr. Basari, the lecturer from FTUI, and he is a leader of UI ventilator. You can see when in my background, you can see the Coven 20 is the ventilator of University of Indonesia. And then all committee and participant of IESC 2020. Oh, sorry, I forgot. FTW Student Union President PASA. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah, in the situation of uncertainty due to COVID-19, not only in Indonesia, but in all of the world, like today, Faculty of Engineering Universitas Indonesia keep performing at the highest level in academic and non-academic area. Like today, we gather here using online platform to have a scientific meeting called the International Engineering Student Conference, or IESC 2020. IESC 2020 with the main theme, Engineering for Sustainable Development, is the conference organized by Faculty of Engineering University of Indonesia, especially to facilitate the engineering student in presenting their idea and research work. I always proud of all students, not only in Faculty of Engineering, but in another university. We have witnesses many big successful company in the world started with idea from student, especially engineering student. Therefore, student conference like IESC is a good platform for students to exercise and sharpen their competence and research ability. This year is IESC 5th. So actually IESC start in 2016 every year and keep improving in terms of number of participants. This year, it's very happy. I was heard from Dr. Munir that participant increased quite big. Both national and international participants. I'm surprised that this year we have the highest number of participants with 231 papers from 44 universities and 7 countries. Big applause of the organizing committee. Certainly, this is a good networking opportunity. Although this year we have many limitations and have to do with online presentation. We hope that the scientific quality of the conference can be maintained. July is the month of Faculty of Engineering. We just celebrate the 56th Dies Natalis of FTUI this month. Many achievements have been accomplished by FTUI from year 1964. So this year, we open one of facility of in Faculty of Engineering. Last year, we have a smart classroom, and this year we have a smart meeting room, and then hope in September this month we'll have a smart building. So all is smart. So because this student like and you know in the this area is all is how to make all its efficiency. So we must do we must have facilities called smart building, smart meeting room, smart classroom, and so on. So thank to the keynote speakers, other and all the lecturer and student committee, BEM FTUI, who work hard to make this IESC 2020 conference successful. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for your incredible speech. As what Dr. Hendricks mentioned before about COVID-20 ventilator, next we will watch a video about Faculty of Engineering, Universitas Indonesia's contribution to COVID-19 outbreak.
Itu sama dengan N3, hampir sama lah. N3 itu minus 4, yang Sulawesi Tengah minus 79. Sehingga kita berpikir, wah ini potensial sekali polisi ini untuk yang radius yang lain.
Oh, that video was very insightful and inspiring to us young engineers. Excellencies, participants, ladies and gentlemen, we are now going to enter our most anticipated event of the day, the keynote session with Dr. Rahmat Adi Wibowo and Dr. Basari Sarjana Teknik. Before that, I would like to remind you during the keynote session, attendees are expected to obey these rules. First, please turn off the microphone and camera to save the bandwidth. Second, do not make any spam chat in the chat section. This session will be moderated by Dr. Badrul Munir, ST MNSC. Ladies and gentlemen, please welcome Mr. Badrul Munir.
Okay, thank you, Mr. Galan, and we are very fortunate to have the keynote speakers today. They are Dr. Basari from Biomedical Engineering Program, Faculty of Engineering, Universitas Indonesia, and also Dr. Rahmat Adi Wibowo, a scientist for photovoltaic system at the Austrian Institute of Technology. Due to time difference between Austria and Indonesia, I think we will have a slightly delay, not delay of the event, but Dr. Rahmat Adi will join us later because now is 5 a.m. Not even 5 a.m. in Vienna. So we will start with Dr. Basari. Dr. Basari is head of Biomedical Engineering Program and also head of Ventilator Universitas Indonesia team, comprised of many teams from many important persons from many institutions, faculty of medical and also industry. So I hope that Dr. Basari will share the story of COFEN 20 ventilators of our proud Universitas Indonesia product, and give the insight or the what is called behind the scene story of the COFEN 20. Dr. Basari graduate from Universitas Indonesia, Faculty of Engineering, Electrical Engineering program. He continued study PhD in Japan, and then returned as a lecturer or professors at the Department of Electrical Engineering, especially since 2 or 3 years ago, we formed this biomedical engineering program. So, Dr. Basari, please take the stage, and you have about 20 to 25 minutes to have the presentation, and then all the participants, you can send your questions after the presentation, or during the presentation you can write in the chat session if you have any question, so we can duly discuss after the presentation. Dr. Basari, please.
I'd like to thank you very much. I'd like to share first about my presentation. Okay, this way. I do hope everyone can view my computer now. Sorry, this one. Okay, this is my presentation. It's okay for viewing my presentation. This
yes.
slide. Okay. So now, my voice and my view of the slide It's okay?
Yes.
Start this presentation. Okay, first of all, we would like to thank for Dr. Badru Munir for inviting me to be one of the keynote speakers today in IESC 2020. And first of all, I would like to introduce, even though already introduced by Dr. Munir, I'm Basari from Biomedical Engineering, Universitas Indonesia, and also I affiliated in the Biomedical Engineering program, including in the undergraduate and also master degree. And also I affiliated in Research Center for Biomedical Engineering, Faculty of Engineering, Universitas Indonesia. And today I would like to share actually about our experience to develop a local ventilator called COVID 20 or COVID Ventilator 2020. Okay, before we enter to the COVID 20, would like to introduce about the biomedical engineering. Maybe some of you already know about the biomedical engineering, the application, etc. But sometimes we don't know about the biomedical engineering. So I would like to introduce that biomedical engineering is applied many of fields, including electrical engineering, mechanical engineering, chemical engineering, optical engineering, or other engineering principles, include materials, etc. To what? To understand, modify, control biologics, including human, especially for human and animal. And then, sorry. And what is actually do that is we design and manufacture products. The products should be can monitor about the physiologic function or even assist. And the assistive product is including for diagnosis or treatment. So one of my presentation today is about the assistive product, that it's a treatment product. And you know, this slide, there are several applications, including prosthetics, arm, yeah, and then the EEG application, or even communication, data communication by shaking hand from transmitter to the receiver, and incubator, like incubator, and then the prosthetic bionics, and other application of the DNA or molecular engineering, and also imaging system. So there are a lot of applications of the biomedical engineering. In this, the world of biomedical engineering, there are a lot of this. So my presentation is one small thing about the biomedical engineering today. So that's why in Universitas Indonesia from 2018, so 2 years ago, we built our stand program in undergraduates called Biomedical Engineering Program. And we have two angkatan, yeah, two generation from 2018 and 2019. And also this year we have a penerimaan or entrance for the undergraduate program as well. Okay, next. Okay, what is the motivation of our sharing today? That we know at today we do the presentation in online because of the COVID-19. So the motivation is actually COVID-19. And especially in Indonesia, I took this slide from this data from the Gugus COVID-19 that the epicentrum of the COVID-19, in fact, infective people is mostly in two areas. that is in DKI Jakarta and East Java. But no, currently the East Java is reached the first rank before DKI Jakarta. So two spots of this epicentrum is very critical in Indonesia. And all of the infection 19 outbreaks spread over all of the provinces in Indonesia, 34 provinces in Indonesia, and more than up to yesterday, that's 90,000 more than 90,000 and 90 million people are infected, and with the death is about 5%, so it's very high, and that is our motivation. So one of several medical devices that needed to overcome this COVID-19, one of them is called ventilator. And I saw in this slide that ventilator necessity in Indonesia is very high, because basically each of the province, the about 20 to 30%. So it's from the covering of all the ventilator in each province. And gugus tugas COVID-19 in Indonesia predict that about actually this is a very surprise that about 30,000 units is needed, actually, even because it's available in Indonesia. And also we know that the facilities, health facilities, mostly centralized in Java. So most of the area in Indonesia out of the Java is minimum of the facility of health facilities. Okay, this is a reason or a motivation to develop a ventilator. Okay, and also this is a fact about the ventilator, that all of the ventilators installed in Indonesia is imported tools or imported ventilator. There is no local ventilator in Indonesia. So 8,000 is surprising that is imported tools. So that's why we need local ventilator made in Indonesia to meet the huge domestic needs in Indonesia. You know, this is taken from Wisma Atlet, that this is always imported ventilator. Okay, what is the ventilator actually? This is simply defined that it's a machine or it's a life support tools that serves to provide breath assistance mechanically to patients, either partial or wholly, in effort to maintain oxygenation. So because of, as you saw in this this slide, that one of the patient is breathless, and then he needs the oxygenation because less oxygen in his lungs. So with ventilator, help him to support him to make oxygenation. Okay, there are a lot of ventilators actually, but basically we can divide it to some types of ventilator. First is called CPAP, or continuous positive airway pressure, or sometimes a resuscitator or resuscitator, sometimes a BVM or back valve mask ventilation, and then other is ICU. Yeah? ICU. What is in the ICU room is ICU ventilator. It's very expensive actually. And another one is transport ventilator. It's like this, a small one that we saw in the previous video. And what is our ventilator actually? Our ventilator is transport ventilator plus with CFAP. So we don't develop yet the ICU ventilator. I think it's next step for develop the ICU ventilator, which is very complex. So we first start from the this ventilator. Okay, so Universitas Indonesia develops for low cost, yeah, and local transport ventilator with the mode is non-invasive but safe and functional for transport emergency ventilator. And basically the working principle of the ventilator or the flow ventilator is pneumatic based. Okay. Why we choose a transport ventilator? Actually, there are several reasons, but we point out about the three main of the reasons. First is about the higher local spare parts in Indonesia for this kind of the ventilator, because if we do or develop ICU ventilator, a lot of spare parts should be imported from the other countries. So to make a fast development, so we need a local spare part. And the second one is a number of the infected people actually is less than under surveillance people or PDP and or even ODP, yeah, ODP. Yeah. So this is the higher needs to support them, PDP or ADP, ODP patient with a ventilator. And our ventilator mode can be set to CPAP mode and CMV mode with additional PIP. Okay, with additional PIP. Okay, that is the reason why we choose transport ventilator. And actually, transport ventilator also can be used for emergency ventilator, that the ventilator is used from home to hospital, or in home care we can do also home care ventilator, but not for ICU ventilator, especially for isolation room ventilator. And this is kind of the modes in ventilation. There are control mode, supported mode, and a combined mode. And we have been developing for this kind of the mode, that is a volume control mode, even though there are limited version of the pressure control in our development ventilator. And of course, we plus with the CPAP, continuous positive airway pressure, with for supported ventilation. Okay, we don't use this combined ventilation mode because actually this is for ICU, This slide shows the specification of COVID-20. Our ventilator is called non-radiative electromedical tools or electromedic devices. And the class of these is 2B in international standard, because in international standard there are 1, 2, and 3. 1, 2A, 2B, and 3. But some in America, in the Europe, is different sometimes. And Indonesia also have 4 division of the medical devices: A, B, C, and D. And C and D. D is the most severe, most risk of the medical devices, that in the group or class C and D must be have clinical trial before market in the market, delivery in market. And this product actually is anesthesia. So this is anesthesia devices and therapy for therapical anesthesia. So that's why we involve in this development with the medical doctor from anesthesia. And the type of product is ventilator transport, as mentioned before. The mode of the ventilation, two modes is control mode and CPAP mode or supported mode. And the control mode is volume control with a mandatory ventilation, and the CPAP for CPAP mode. And also inspiration to expiration ratio, 1 to 1, 1 to 2 is mostly used in current situation with the respiration rates only for adults. We still developing, actually we can do for the child and even the baby, but it's strict, more strictly, so that's why we focus on the adult people with a table that will follow from 300 to 600 milliliter is for adults actually, because for baby or infant or children is less than 300 milliliter. And with additional PEEP, and whereas the inspiration pressure limited to 45 centimeter at H2O, and the oxygen rate is from 60 to 100%. With some the accessories and the dimension of our developed ventilator is very small, actually about 34 centimeter to 28 centimeters. And we do battery, we include this battery. So basically the ventilator is operated with a battery system. With if the battery lows or low battery, and then just plug into AC alternating current plug to make a charger. And the weight of this ventilator is less than actually 3.5 kilograms. Okay, this is the excellencies of the coven already presented in the video, so I do not explain again, but one of the important thing that is, this is cost effective, because the fabrication and the spare part of this ventilator is very less compared to the a commercial product. It's about 1/3, yeah? 1/3 of the fabrication cost of this product from the commercial. And I would like to share about how ventilators work. For example, this is the installation from the hospital of the gas oxygen hospital, and or can be from oxygen tube, and then going to the regulator, and to regulate the pressure, and can be mixed with oxygen from the air, because to minimize the oxygen. And then we take the sensor, pressure and flow sensor, with the control here, and the control will make operate of the solenoid valve to switch on and off of the gas flow of the oxygen. And the controller is supplied by battery here, and battery is supplied by charging, and can be displayed in LCD display. And after that, the gas flow, oxygen gas flow can be delivered to the patient. And if there are several unexpected situation, the alarm can, we install alarm here for low bed alarm or no oxygen alarm, etc. And actually our developed ventilator has been patented. This number of patent. So first, if you want to develop your products, you need to apply the patent, or if you have the copyright, you apply the copyright. And if you have design of IC, you apply for layout design of IC. Even if you make offer to the industry, so you can make applying for industrial design as well. And this is the license or I mean filing proof of the patent and copyright. So then I would like to share about the progress of COFAN 20. Actually, we developed with several progress of the COFAN. Sorry. Okay. The progress of COFAN 20 prototype. First, we developed the lab prototype 1, and then we developed second one, and the last is for industrial production. And this is the last of our industrial production. And before that, actually, we make several product testing before. After you develop the product, and then we should test the product. And several of the agency can test the product. One of them is the BFK, Ministry of Health. And this is the flow of the product testing. First with the technical guidance, and then product test. We did the product test about 10 days, yeah, about 10 days, and then we have we pass our product pass in the product testing, and we have and then we do the clinical trials, because as I mentioned before that our product is actually a C group or C class with the high risk or medium risk. So we need the clinical trials in cooperation with the Faculty of Medicine, Universitas Indonesia, with the medical doctor from the RSCM, Cipto Mangunkusumo Hospital, and also RSUI, Universitas Indonesia Hospital, and Rumah Sakit Persahabatan, Jakarta Timur. We did the clinical trials, included 2 modes with CME mode and CPAP mode. And this is a venue tool and documentation. This is the result of the clinical trials, CMP mode, with a good one, even with the arts situation. Art situation is simulate the COVID-19 patient. And also this is clinical result with the CPAP, one of the situation of the patient that use our devices or tools in RSCM hospital. Okay, and then after that, after clinical trials finish, then we apply for, it's called marketing license or izin edar, marketing license to Ministry of Health, Republic of Indonesia. This license actually held by industry. So before we make an agreement with industry that applying the license, and we have 2 licenses here for izin edar or marketing license from GTM and from EMB. This PT GTM and this is PT EMB. So we are legal to distribute our product. That is our flow actually. And we entered in the production of the COFAN 20. First, we product about 300 units of the ventilator. Now in still progress, and actually already more than half is already product in our industry, and this is the view how the process of the production. So this line product in our industry, and then we assist some technical guidance in the industry, and then we have this product, and also we check again in our laboratory, and then we deliver. We are ready to deliver to the hospitals in Indonesia, and this delivery process to the hospital, and also after delivery we make a training of our COVID 20. Make sure that tenaga kesehatan or medical care can use our COVID 20. And actually the distribution area of the COVID 20 is cover all of the area in Indonesia province from Aceh to Papua, and we expect that now is expect that 300 units can be covered all of Indonesia, and up to now is about 100 already delivered in the Kalimantan, Sumatra, and Java area. And would like to thanks for partnership all of the agency or the faculty in the Universitas Indonesia, especially for Faculty of Engineering and Faculty of Medicine, and also some hospitals, and also for Polytechnic, Polytechnic Negeri Jakarta. And this is production distribution from some of the industry, GTM and Pindad, and also spare parts component from Kempo, and delivery from Daruma, and spare part also from PT Usra. And like also thanks for fundraising and crowdfunding by alumni of Faculty of Engineering. And this is COVID 20 team, especially is very huge team, because we cannot do everything by a small team. We need to cover all team from the engineering team, medical doctors team. Also, we involve the students in this COVID 20 development. And also we need a support team from finance, fabrication, fundraising, etc. So we'd like to thank for all of the involved in this COVID 20 development. Thank you very much for your cooperation and attention. Thank you.
Okay, Dr. Basari, thank you very much. I would like to invite maybe one or two questions before I continue with the next keynote. You can raise your hand and or write the question in the chat session. Okay, I will not stop for long. So because okay, one question, I think, okay, two questions. Dr. Basari, you can answer this. First question is about how about the durability of the COVID 20 after implementation. And the second one is what is the upcoming development in your group, your team, or in RCBE? I think this is also very interesting. You can talk more about RCBE. Thank you.
Okay, thank you very much for the question. I'm trying to answer the question. First question about the is it?
Durability.
Durability, sorry. Durability. Our COVEN 20 durability, you know, as I mentioned in this presentation that we did the product test, product test. Okay. Sorry. Product test. And the product test by BPFK, Ministry of Health, is we done up to
Basari, are you there?
From the is tested about 2 by 24 hours with the operation. So we did this, and we passed of this testing. Okay, and about the so that's just because of we passed the testing of the durability testing in the BPFK. So basically our product is safe during operation. So sometimes the agency make more than 2 by 24 hours, sometimes 3 by 24 hours, or even 1 week. But in this time, in BPFK is about 2 by 24 hours. We do not perform yet for our product durability more than 1 week or with the full operation, because actually the operation of the ventilator is sometimes 2 hours, 3 hours, even though sometimes more, sometimes also can be 1 week. It depends on the patient. So this is my answer actually. And the second answer about the future development of COVEN 20, because you know that our COVEN 20 is for transport and emergency ventilation, and we currently already or have been done for the small ventilator. Currently, small ventilator. We don't need again for sometimes, you know, there are many of the part of this, especially for this kind of the components. So we currently make some simple of this to make a small one, and with the display touch screen display, and can be controlled from, for example, from handphone. So that is the product is can be used in home caring, not in hospital. Even though actually can be used in hospital. Now it's currently we are developing this, and then the second is for ICU ventilator. That is our dream to develop the ICU ventilator. With this, actually the mode is combined mode. It means if because COVEN 20 is only for supported and control. It means for people who still live. I mean wake up for supported, but this is because we do anesthesia, so the patient is knocked down. So this is control and supported. And if the knocked down patient and then immediately wake up, so we need to know the feedback from the patient and then make support to the patient. So we change to the other, other mode. That is ICU ventilation. Now is going to ICU ventilation. That is our next future development. Thank you. I think this is my answer.
Okay, thank you very much, Pak Basari. And we have more questions from the audience. I think what is the constraint of local product research? One of the constraints of the local product research in Indonesia is trust from public. How to support the mass production? I think there are many stories behind this. And and the next question, how much does it cost per unit? Okay.
Okay, maybe the last one first. The last one about the cost of the production. I told before that it's about 1/3 from the commercial. If you know the commercial of the transport ventilator, like in this slide, in this slide is a commercial product. It's about more than 1 million rupiah, 100 million, more than 100 million rupiah, about 150 million rupiah. So in our cases, less, currently still not commercial actually, but for donation, so it's 25 million rupiah for donation. But for commercial, we need to calculate again. But I think the price is not less than 100, or even less than 70 million rupiah. I think that is our cost. And about the constraint for developing in this ventilator, there are a lot of constraints for developing of the ventilator. Up to today, our team working for more than 100 days. So there are a lot of constraints, especially in regulation, because the regulation is very strict. Even in COVID-19, there are several open of the regulation. So the strict regulation can be deal with some specialization regulation that we and actually because of the support from Universitas Indonesia, especially for Faculty of Engineering, in this team there are a lot of Faculty of Engineering team, even from a medical doctor teams. Without of them, we cannot do. So the main constraint, we must work together. If we cannot work in teamwork, so we cannot develop, or we cannot make our dreams come true. So that is a concern, basically for internal, and then external is like regulation and industrial partnership, also some constraint. So this is we need to improve our skill, not only in the engineering field skill, but also in other field skill. That is very important.
Okay, thank you. Yeah. Thank you very much, Dr. Basari. I'm also part of this COP20 team, especially I'm responsible for fundraising and distribution. And we feel that many disciplines need to collaborate closely to make one product successfully, especially commercially. Okay, more questions are welcome for Dr. Basari, but will be discussed after Dr. Adi's presentation.
Okay.
Now we already have Dr. Adi.
Okay.
Thank you very much, Dr. Basari, and
Thank you
applause
very
to
much.
him.
Thank you very much.
We have actually the clap system here, but that's okay. Yeah, okay. And now we have Dr. Ahmad Adi Wibowo. I hope he already wake up enough to start this his keynote, because it's 5:30 a.m. in Wina, I guess, and
it's already sunrise here, Dr.
Oh, okay. Okay, a bit description or introduction about Dr. Adi. The most importantly is he was my lab mate in Korea for 4 years. So we share a lot of things, foods and etc. So I guess it's better he introduce himself, but I think for us, Faculty of Engineering, we are very proud that he is one of our alumni and work abroad in Austrian Institute of Technology, and also contributes a lot to collaboration with our university. He will talk about exploitation strategy from research to market. So it's closely related to Dr. Basari's work. Dr. Basari works is more on specific product, but Dr. Adi maybe can add something or can have a broaden view about how to market the products. 4 minutes already passed, so please, Dr. Adi, you can test your screen and also start your screen and test your voice maybe already. So time is yours.
Okay, thank you very much, Dr. Munir, for the short introduction. So I hope my screen now works properly. So yes, many thanks for the invitations, and good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. As Dr. Munir introduced already previously, so my name is Ahmad Adi Wibowo. So basically, I'm alumni as well from Faculty of Engineering, University of Indonesia. But now I work in Vienna, in Austria. My institution is the Austrian Institute of Technology, and I work with photovoltaic systems. The department works with the solar cells developments. My background actually is material science, so I work mostly on the material system, physics, chemistry, and so on. So mostly working with the heart of the solar cells, how to make it, how to fabricate it. So it was nice to be here with all of you, all of the participants of the IESC, and many thanks for invitation again. And I would like to say hello to Mr. Dean, Dr. Henry Budiono, and the previous speaker, Dr. Basari, for his contribution for the development of the very urgent tools, for against our COVID-19 pandemic, especially in Indonesia. So actually, I just would like to introduce the AIT. If you have not been knowing so far, the AIT is the largest research institute, non-academic, non-university institute in Austria. Excuse me. And this is our campus in Vienna, in the north part, and we have quite a lot of activity. But if I would like to say that AIT in Indonesia is almost similar to what BPPT or Badan Pengkajian dan penerapan teknologi work so far, which is close to the applied science, not on the basic science like the university. And at a glance, let's say, perhaps also introductions about the Austrian research community, let's say, or how we in Austria develop our scientific contributions can be represented by these two, let's say, informations. First is actually, not many know actually, so Austria is the largest country for R&D expenditure in terms of the ratio of the R&D with its GDP. So now we have about 3.19% the ratio of the research and development expenditure to our GDP, which is 3.19, and it's quite huge, basically, in terms of the R&D ratio, because we know that most of the country low or something like the limits of how one can define itself as a developed country is about to have a 2% R&D GDP ratio compared with the other, like for instance, developing country. But Austria is top rank on number 6 or number 7 in the world, and even is larger than the ratio of EU GDP contributions of the R&D to GDP contribution, about the 2-point-something%. And this is a good example how a small country, actually Austria has a population less than Jakarta. So it's only 9.5 million people here in total, but the country can provide quite enough financial support for any research and development, especially also study for master or PhD courses in Austria, so that they can sustain their economy, basically. So the funding comes from a lot of sources, like from the Horizon 2020 of the European Union funding, and the Austrian Science Fund, and also Austrian Economy Fund, and especially the Austrian Research Promotion Agency, which will be described further in my presentations. So this is important, why I introduced a bit about the AIT, the business model. Business model means that how an institute and company work in doing his or its business, basically, or activity. Like in AIT, we have 8 big centers. So perhaps in university in Indonesia, we call this as a faculty. So I belong to the Center for Energy, works with the energy infrastructure, with the renewable energy, sustainable building, solar thermal, and the complex energy systems, which are maybe represented in electrical engineering in University of Indonesia or most of Indonesian university. But the other works also on low, for instance, low emissions transport, like the electric vehicles, mobility systems, like how the infrastructure in the railroad or in the traffic system behaves, and also health and biomedical system or bioresources that works with vaccine, with the antibody and so on. But what I would like to emphasize here, actually, the position of the AIT is not a basic science. So it's most closer to the industry, closer to the applied science, and which means that we support mostly the industry instead of promoting the basic science like in university. So this is the position of the AIT, or Austrian Institute of Technology. If you ever heard about the technology readiness level, or TRL, So this is very famous to define the position of, let's say, a research activity in some institutes, let's say. For instance, university in general, I talk about the general terms. In university, so mostly, most university works on the basic science, like the idea, the basic research or proof of concept until TRL2, or perhaps as far as TRL3 or applied research. So it is like something like to prove the concept of the technology that's being developed. So this is the domain activity of the University of Basics University, which is in the basic science R&D, and going a bit higher TRL level. So we are here, basically the AIT works mostly on TRL 2, 3, 4, or as far as TRL 5, large scale prototype, depending on how we collaborate or we do the research activities. And we have in Austria and in many countries in Europe, we have the competence center. So it is the center who focuses on some activities, like there is a center for corrosions only in Austria. There is a center for polymer in small city in the Alps region, in the Leoben, for instance. And there are center for printing technology and so on. And then the other is the industry, for sure. For industry works on the higher TRL level from, let's say, 5 to 9. From the prototype, excuse me, from the prototype until the full commercial applications. So you can see that actually the AIT does not produce any product in terms of we sell something. It's almost similar like university, like previous presentations, the COVAN20, which is produced by University of Indonesia, but collaborate with the industry for commercialization or marketing purpose, and perhaps for distribution as well, if I'm not mistaken. But the industry works mostly on producing something or producing the service and close to the commercial application, of course, close to the market, close to customer. But AIT supports the industry or support the competence center to, let's say, to do or to improve their productions or to improve their R&D activities, to help their missions or visions to develop a new technology or to attain the new markets. So this is important because for the bringing idea to market, you see that the position of the institute like AIT is just to bridge, actually, to make a bridge between the basic science into the market, how to bring the idea or to collect the basic principle of sciences into more useful technological product. So this is the activity of our group. Basically, I don't put slides for introducing our group. Actually, our group work closely with 3 bodies, let's say, in Austria. First is the academic body, the funding bodies, and the industrial partner. So we see that we are working closely at the moment with the university in Austria, in Switzerland, in Berlin, in Germany, and also we work closely with the industrial partners, start from the small and medium enterprises into large, well-known companies. So I can say that there are some startups even. So there's Crystal Sol is the producer of the thin film solar cells, the solar cell that can be bended, the flexible solar cells. Sunblood also is a startup company in Austria who has been working on at least 7 years for producing the solar cells. And for someone who works with the dye sensitized solar cells or any type of the hybrid liquid solar cell, you must be you must know the company of Solaronics is from Switzerland, who works or who produced some part of the solar cells. So the question now is, how can we do the research and development? Of course, as a research institute, we are depending on the funding body. So we have here FFK, or Austrian Promotion Research Promotion Agency, and Climate Energy Fund for supporting any research activity, especially the new renewable energy. Solar Aeronet is the one that I would like to present here. Is a program from European Union, European Commissions, who support the activity of research in solar cells. And OEID is maybe it's also important for you, for all of the student participants in this events. Actually, the OEID is the Austrian academic exchange funding. So this is like the body in Austria who gives scholarships in master and PhD or a postdoc to have a further academic educations in Austria. So if you are interested with the OEIDs, you just search the OEID in the website, and you will see there are quite a lot of opportunity to have let's say, not only collaboration, but also to have a further education developments in Austria. So these three are the main actor actually who supports the R&D activities in Austria, besides of course the AIT. So how we do the research, basically we always work closely with academic funding body and industry. So this is a slightly introduction of the activity, and then one of the outcomes for sure, because we are the research institute, we are motivated, we are very motivating on producing something, of course, because we don't produce a product or service, we produce patents or publications. So this is the publications, for instance, to show how collaboration between the AIT, between the research institute, university, and the industry partner in Austria also contributes to the scientific progress. So this is an example of the group publication in thin film solar cells, and I hope this is one of the description how we work so far. This is one of the representation what is the outcome basically of the collaboration of the research in so how it works basically. So this is almost similar story actually with COVID-19 ventilator in the University of Indonesia, COVID-20. Basically, the general term is how to transform an idea into something works, something that works, and something that can be commercialized or exploited. So basically, it's not the term in the research activity, in the research community, is not about commercializations, but the term is about the exploitations. So I will explain later on why we call this exploitation rather than commercializations. So here is the idea comes from actually how we got the idea how to market something new, or to implement the research outcomes in an industry activity, or in the closing to the commercialization or exploitation of one product. So let's say we start from from a company in Austria. This is a good example because this is a real project which is done until last year in 2019. So one of the companies of Fremeco, let's say, it is a sulfide-based powder manufacturer. So sulfide means like the compound consisting of sulfur, like the iron sulfide, tin sulfide, copper sulfide, and so on. But they produce it not in the bulk, but in the powder. So the powder of the sulfide compound, which is being used as a brake part in the car. So it is a brake part. And it's quite well known, a company who produce this kind of materials, especially tin sulfide. But now Fremeco thinks about the future, let's say. Any company wants to have the economic or market growth by expanding their portfolio, but they have limitations. First is human resources, because it is a small, medium company, a technological-based company, and they also limited by their financial issues, for sure. I mean, for doing research and development, you need investment. So the company, any company cannot do that by themselves. So they need support from other party. And then they don't have the intellectual resources. It means that they don't have, let's say, brain who focus on research and development of their product. So, so based on this limitation, for sure, they cannot they cannot support everything, including the capital, research, and markets. So they need a partner. Let's say we call that as partner. The R&D partner is us, the AIT, our group, and for the intellectual resources, let's say, and funding supports, money, how the additional money for investing in research and development comes from. It's coming from all of this funding body in Austria. So this is the typical situation, actually, basically everywhere, not only in Austria, in Europe, but also in Japan, in United States, Canada, or even in Indonesia, that every company wants to grow, wants to have improvement in their product or services, or increasing the lifetime of the product, but they don't have capacity to do research by themselves, and they don't have a funding support to do it by themselves, of course. So how the idea then comes? Since the company produce a sulfide powder, so it's sulfide-based powder, so then, and they come to us, let's say, and then we propose them to do something really new. So this is some introductions about the materials that we want to do in this project. We call this earth abundance materials, photovoltaic absorber. We call this is copper zinc tin sulfide. This is new, quite emerging materials for thin film solar cells. And I will not explain in detail about this one. But if you want to see the structure of the solar cell, it is very thin. In total, perhaps only 2 to 2.5 micron thick of the cells produce electricity. So this is the typical example of the copper zinc tin sulfide thin film solar cells. So this is the idea. So actually, so why don't you produce a sulfide compound that can be used as the solar cells and can be used even more to have a kind of a flexible solar cells. So you know that solar cells is silicon, and you can see if you put it in the rooftop in the building, so you see something like bluish color panel cells. That is the silicon solar cells. But since we want to know something new, we want to make something new, so we try to use the sulfide powder into thin film photovoltaic or thin film solar cells materials using printing technology. So this is the idea how to use it, because there is an added value of the product if you can make a thin film flexible solar cell. This is just an example or the representation of how a solar cell can be made by printing technology. So you can see that this is the plastic or polymer. So you can coat or you can deposit or you can print basically solar cells, and then it is the process of the roll to roll, so that you can produce the solar cell with the almost unlimited length, let's say. So this is the idea, how to produce a powder that can be used as thin film solar cell materials and using printing technologies. So this is the first idea. And the second is the next step is we went to a funding scheme. So we were looking for a suitable funding frame, which is available at the moment in Europe or in Austria. So one of them are Solar EraNet. This is a European program for promoting research and development for solar cells or solar energy, basically. So the name is Solar ERA, it's Solar European Research Alliance. So AIT is also a part of the European Research Alliance, so we have opportunity to be in the competition, let's say, to get the funding. So for information, all the funding are on competition base, on the competitive base. So even there is a funding, but we have to compete each other with the other institute, let's say, to get all the funding that we need, basically. At that time, actually, there were a Solar EraNet, which was really suitable for our idea. Then we have another problem. Since this is European project, so we need at least 2 countries, 2 participant countries, not only from Austria, to be eligible to get the funding. So this is a lot of trick, basically, for getting funding in Europe. So the program is quite a lot, but the competition is high. So this is everywhere, basically. So it's not only in Austria, in the University of Indonesia or Indonesia in general also have the same issue, for sure, because the funding is limited, but the research and ideas are unlimited. So this is the one of the problem. So since we need another partner from basically from other country outside Austria, then we need to to collect, let's say, another expertise. Since the Freemaco produce only powder, so only copper sulfide, tin sulfide, and zinc sulfide, so we need someone or another industry, another partner who can mill it, who can reduce the size of the powder. This is the Austrian company who mills the powder until nanoscale, in nanometer size. And then afterwards, we also need a partner or expertise who can turn the powder into the printing ink. Because if you heard about the printing technology, then we need an ink. So it's like we want to print a paper on DeskJet or HP printer. We also need not only the paper, but also. So a UK company, which is also in the Solar EraNet program, can produce the ink for printing technology and the ink formulation, how to make the ink suitable for each printing technology, like the inkjet printing, like the screen printing, and like a 3D printing as well. But in our case, we just need someone who turns the powder into the ink so that we can use as a thin film solar cells. So this is the story behind how we got the project at the time. So we are collection of 2 countries. We are the partner from 2 countries. We are actually, our project consists of 4 partners, 3 industrial partners and us, and AIT. So the problem is about funding is everywhere basically is you will not get 100% funding. So in this case, in Europe, in Austria, normally we talk about funding rate. So this is how much funding we can receive for each institute depending on the status. So the status of AIT is a research institute, so we have privilege to have 85% funding. So it means that if the project costs about 100,000, so we will get only 85,000, and the rest 50,000 comes from our own pockets. Let's say the research institute should have their own funding, liquid equity for support the activity. Yeah. And this is also happens with all, like the the small enterprises get only 70% maximum. So 30% funding comes from their own pockets. And the FRIMECO is actually a medium scale enterprise after evaluating their status of the industry, the status of company, so that they get only 60%. So the funding will not cover all of the project, all of the research activities, but most of the part of the project are covered basically. So this is the information that I would like to share basically about the funding rates. Mostly in Europe is working like this. So then after we got the partners, after we got the funding, after we got the idea for sure, and then we wrote the proposals and so on. So then in order to bring the idea into something useful for the public, and then we have to define, start from the beginning, what is how we disseminate the project results and how we exploit the project results. So this is the 2 things that difference in terms of research and development language. First is dissemination is something like about the scientific results, basically. So like conferences, publications in journals, or even we publish the picture of the result product, let's say in LinkedIn, in Facebook, or ResearchGate, or even in news or mass media. Sometimes we had advertorial also in the mass media, or even maybe perhaps a TV interview and so on, or even just to put the project result in our own corporate, our own AIT website. So all of these are categorized as disseminating the project result. But now which is relevant for us now is the exploitations. So this is what we call as commercializations in the research terms. So exploitation is everything about how to get money, basically. How to get money from the economical point of view of the project results, like patents that we discussed previously during the COF20 presentations, and also how to license it, how to sell the license into industry and so on. So this is the terms that we call exploitation rather than commercializations. Then the exploitation strategy basically has two aspects. One is about the early adopter, and second one about end user. So the PAL, the UK company who works on the ink, has already been in our project as early adopter. So they adapt as the first institute who tried to make the ink out of the copper sulfide, tin sulfide, and zinc sulfide powder. And FRIMECO is the one who will use the project result on how to synthesize the powder for solar cell applications. So start from beginning, we have already defined two very important partners who works as end user, and the second is the early adopter. So both of them will be the final judge, actually, whether the project is successful or not. So for the dissemination, this is one of our disseminating results presented in a paper and in the conferences, but I will not discuss this detail. Perhaps if you would like to know much detail about this, so please, we can ask this in Q&A session. But just remember that AIT is a research institute working with a company. So one of the emphasize how to use this research output is to publish it externally in a publication journal or in conference, because remember that 85%, 70% funding comes from the taxpayer, from the citizens of Austria, in the form of tax, and then coming to us as research funding. About 70 to 85%, and one of the rights of the research institute is to publish the results after have an agreement with the industrial partner. So I think this is the last presentations because I think the time is quite run very fast. So this is one, for example, from the 3 years project, we published 2 papers in journals because this is the right. And also sometimes it's obligation for us to publish scientific journals. And we attended the 4 conferences. And of course, similar to the COFEN 20, I think it is necessary for us to patent this is in German, this is the ink for productions of semiconductor layer. So the solar cells is a semiconductor. So this is one of the way how to produce solar cells. So I think for the solar cells itself, it's maybe not a topics of presentation, but what I would like to spread the message here in IESC is first, the industrial partner is necessary for sure to communicate the idea, because without them we cannot exploit or we cannot commercialize the idea, and should be communicated start from the first time, from the idea generations, and of course they are needed, the industrial partner are needed for ensure the technological and knowledge transfer from lab to fab, basically. And of course, it's similar idea with Dr. Basari that we need to patent. We need to file a patent for every, not for every, depending on the commercialization potential of the product or service. So we are really motivated to file a patent, and we got one of that patent from this European project. So I think that's all, Dr. Munir, for the presentation of my part. So I think I am looking forward for the question and answer. I hope this will be useful for all of us. Thank you very much.
Thank you very much. It's a very, very nice presentation and very sequential and also very detailed with great examples of the success of the project, and also very nice ending with the picture. I was there, so it's a great picture. Thank you, Dr. Adi, and I think we need to give a big applause for Dr. Adi first, and then the questions. We have 2 questions, or 3 questions actually, but the third question I think belong to both speakers. We have about 3 to 5 minutes. I hope everyone do not bother to extend the session about 5 minutes. So, question from Maurice. I would like to ask a question for artificial photosynthesis. Dr. Adi and can read also in the chat session that applies in photovoltaic electrochemical system. Do you think it's applicable in Indonesia? That's the first question. And the second question is, what's the major problem if we make collaboration with industry to fund our project, and how to solve the problem? And if the research is not success, how to make the report accountable to the funder? I think Dr. Adi can discuss about these two questions.
Yeah, thank you very much for the questions, and thank you for reading, informing the questions, Dr. Munir. Okay, for the photoelectrochemical cells, I think everyone knows what photoelectrochemical cells is. So it's a cells that split the water into the hydrogens, and this is also hot issues, hot research topics in Europe. Especially about if I can mention about the issue of the global warming. So we don't want to have any more carbon or fossil-based fuel, basically. So hydrogen generation is one of the hot activities in Europe, basically. So for the CCTS itself, if you see the materials here, I would like to speak in more detail here, actually, but of course it's not the right time. So basically, yes, it can be applied as a photoelectrochemical cells, of course, with the same structure. So we have the P-type, the N-type, and front contact. You can basically use it for splitting the water, provided that you have correct photoelectrochemical cells arrangements. So I tried this in the laboratory, and it works. But we don't publish it because it's really very early stage of developments in our group, and we are looking forward to have the project with this, especially with the university, because the photoelectrochemical cells are not technologically mature, so it's not established already in the markets. So for the second questions, I guess it's about if the project is not successful, and how we report it to the research funding. So basically, from my experience, actually, from 3 years project, or of course there are a lot of three running project currently in our group. The aims is one thing that we are ideally want to achieve, basically, but it's always happened that in the meantime of the project we got something new, because we tried a lot of things, and somehow we can publish in the meantime, or we can make a file. We can file a patents about one thing that unexpected happened during the project, during its running. So basically, the research funding in Europe, in Austria, does not emphasize on the achievement of a research project. Like, for instance, I want to make in the project a solar cell with efficiency 20%, which is of course very ambitious. But at the end, I just achieve 10%. How we report this? So what happened is we emphasize the achievement of the project. If we cannot achieve 20%, but we emphasize that during the project, even we have 10% efficiency, we achieve something new, like the composition of the cells, like the how do you call this, like how to fabricating the cells with something new, and so on. So basically, research funding in Europe or Austria is not like a killer, like a monster that when you don't achieve your aim numerically or 20% efficient, then you will not get the funding. So it's not like that. So I mean, it's the funding itself. I think it's just to promote the activity of research. Once the activity shows the support to the company, then we have no problem, actually. And the company will not suffer so much if the project is failed, because the funding, 70% funding comes from research funding. So they don't 100% invest in the project. So I think that's the brief answer from my side.
Okay, and next question, does the AIT work with researchers from other countries outside Europe? I think I can answer this because I was there and I saw many Indians and also Indonesians in the research group. So we have a short time. I will continue with the next question. Do all research have to be commercialized? This, I think, for Dr. Basari also, please answer this.
Okay, I'm trying to answer about if we do a research, do we have to apply for commercial? It depends on, I think Dr. Adi already mentioned in the presentation that not all of our product or all of our research product can be commercialized. It means that it depends on the market. If you feel that the market is huge and needs your product, so it's I think you need to make a commercial. But actually, before you decide to commercialize the product, I think the step how to research is you cannot research by your own willing. I mean, I want to research this topic, but actually this topic is not needed in the market, or even market doesn't need this type of the product. So I think in the first step, you need to take a survey or take a market is a need, what kind of the product that needs in market. In the field of biomedical engineering, for example, medical devices. So there are a lot of medical devices actually in the market, especially you can observe in the hospitals what kind of the devices that need for medical doctor use, and you take a survey with or take a questionnaire with the doctor, or take an interview with the doctor, medical doctors, what kind of the devices they need. So from this step, then you think to do a research about this product, and then step is like Dr. Adi said.
Okay, Dr. Adi.
Yes, thanks for the question. The answer is no. It's not necessary all of the e-commerce. It depends on how someone would like to use the exploitations aspect. I mean, of course, one of the most important research outcome from a scientific project is the knowledge, for sure. So of course, from the knowledge, you can improve something, but sometimes the company or the industry doesn't think the same way as we think. Yeah, we as a scientist or professors in university or research institute, we always think that this is something new and it is really very potential to be implemented, and it can help a lot of people and so on. But the industry doesn't think the same way, because they always calculate something. Yeah, like Dr. Basari say that sometimes it's new and the industry does not see that there is an economic potential on it. But one thing that we need to emphasize is that every scientific project, scientific research and development produce a knowledge, what we call is foreground knowledge. So it can be improve the process in even the industry who does not interested to commercialize it. Yeah. So I think that's my just short answer. It's not necessary. The problem is how to communicate these not necessary things to other, because this is also important, because if you think that all the project needs to be commercialized, then we are dead. So that's my answer, Mr. Dr.
Okay. I can add some things. These days, not everything must be commercialized, because you can achieve your success not always in the commercial way. Now, becoming a trend to do like sociopreneurship, where we don't commercialize, but we increase the exposure and the involvement of the public by social things. I think that's another aspect. Maybe we can have another discussion on that. Okay, I think one last question, because Dr. Adi, I missed one question from Didier. Does AIT work with researchers from other countries outside Europe? I think, do you have a project with other research institute outside Europe?
Outside Europe, if you ask about AIT, we do have outside from Japan, from China. So there are a program between the Chinese Academy of Sciences and Austrian Academy of Sciences, and we do a European project with I think from Japan. So this is one of the example. And of course, if the question is directed to whether there is an opportunity to have an Austrian-Indonesian collaboration, of course there is an opportunity. The thing is, we need to find a program for it, because one of my suggestions from OEID, I presented in the presentations from the OEID, so we can explore some programs that can be used for having research collaborations. That's my short answer.
Okay, I promise this is one last question. How do you see the development and implementation of renewable energy in Indonesia? I think it's your expertise in our group.
Yes, thank you. This is a good question, because renewable energy is not the problem in Indonesia right now. Actually, it's a problem of the global community, because it's not only about the future of the fossil fuel like oil, but it's also about the environment, basically. So we are, in Europe, there is no debate about the green energy, because we are going there, actually. So with the hydrogen, with photoelectrochemical cells, with the solar cells, all technology that produce low carbon emission is a very hot topic. We are going there. We don't have any choice as a scientist, because we need to go there, because all the funding program are directed to low carbon technology. The question is, Indonesia will follow, when Indonesia will follow questions like that, because United States also in the status like Indonesia, they are in the middle of the debate whether the green energy will take the old fashion of fossil energy. So this is the question is just a matter of time whether Indonesia will follow, not follow the trend, or follow, but it's going to be on the same level or not with other country. It's soon or later, it will be the same way. I mean, maybe 20 years, 5 years later, while European maybe in 10 years can fulfill their targets. So the question is like that, Mr. Munda. I think the renewable energy will be sooner or later will be the choice.
Okay, thank you very much. We have a great talk today with two our keynote speakers, and I do not need to summarize things. We already learned a lot of things from the beginning of the research into commercialization. Thank you very much, Dr. Basari and Dr. Adi. We would like to invite or to ask all participants to turn on their videos for taking a picture, if you're not mind. And I will return the session to MC. Please take care of this. Thank you very much, and big applause to all keynote speakers today.
Thank you very much for having me. Thank you.
Okay, Kalan, please take a picture of every page here.
Okay.
And
okay.
I think the committee at the backside will take it.
Because there are about 200 people in this Zoom meeting, please kindly hold your pause until I finish my counting. I'm going to count 1, 2, 3 repeatedly until 10 times because there are 10 pages in this Zoom meeting. Okay. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Thank you for your patience to wait until I finish my count. Well, what an excellent presentation from our keynote speakers. We can learn many things from both of them. Thank you to all the speakers, Dr. Rahmat Adi Wibowo and Dr. Basari, Sarjana Teknik, Master of Engineering. Thank you for Dr. Insinyur Henry D.S. Budiono, Master of Engineering. Thank you for Dr. Badrul Munir, Sarjana Teknik, Master of Science in Engineering, as our moderator today. Thank you to all participants and the audience for coming to the opening ceremony. Now, I would leave you with a quote by Stuart Brand, an author and an innovative thinker, who once said, "We can see the past but not influence it. We can influence the future but not see it." Let us all be guided by all the things we have learned and heard throughout the conference and be able to see and influence our future. Thank you very much for your attention and cooperation. Till we meet again, perhaps in the next conference, may all of you stay healthy during this pandemic. Okay, for all participants, don't forget to join the conference room according to the measure of the paper. I am God Magita. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you. Bye.